With the need for cheap renewable energy, it's important that every possible source of energy is exploited. Currently, wind and solar are given most attention, the reason being that both these technologies are mature and easy to construct. Ocean generators haven't been given that much attention due to its excessive startup costs. There are, however, some really impressive technologies out there. For example, the Ceto, Powerboy, Palamis, to name just a few, all producing very expensive, very impressive results. This proves the validity of ocean generators. The design proposed is probably not the most elegant of solutions, but it's not meant to be. If the technologies mentioned above is the Rolls-Royce of ocean generation, this design would probably be the Fiat Punto. It's got less features, but it still gets the job done, but for cheaper. The concept works as follows. First, we need to construct a couple of floats. I propose we use recycled material just to keep the costs down. So, for example, collect a couple of plastic bottles, whatever, tie them all together at the handles, and use fishing net just to secure the whole lot. Next comes the generator. Again, keeping it as simple as possible. Use a PVC pipe and wrap copper coil around that. Next, get a magnet and let that slide on the inside of the pipe. This will function as the armature and will stay on the shore. The next step is to connect this float to this magnet in the pipe. The idea is that the up and down motion of the ocean will cause the magnet to rise and fall on the inside of the pipe, creating an electric field. This is done as follows. Step 1. Attach a fishing rope or cable to an anchor. Step 2. Attach this rope to a pulley. Make sure the distance between the anchor and the pulley is roughly a meter or so below the surface of the ocean. Another rope is then attached to the float and guided through the pulley and redirected to shore. At the shore, another couple of pulleys is used to guide the cable to the magnets. Attach the magnet to the cable, and voila, a generator is born. The design is simple enough, but what about its maintenance? The floats are obvious. When they start to degrade, simply take them off and put on a new pair. If the ropes of the cable start to degrade, simply attach a fresh one at the end of the old one and simply reel the new one through. If the pulley starts to degrade, simply grab hold of the rope connected to the anchor and raise the whole system up, attach it, place it with a fresh one, and let the whole system down again. As you can see, no divers are required, and very little technical or mechanical expertise is needed, making it ideal for rural communities. Most importantly, it's affordable. Now you've seen the basic concept. Now it's important to just look at a couple of possible improvements that can be made on the design. First, the one anchor per float has a problem because it allows for drift, which may allow the float to tangle with the other floats in the area. To solve this, I propose a honeycomb deployment. Each anchor has a couple of ropes and a pulley attached to it. Each float in turn is then connected to a few anchors at a time. This stops the drift and lessens the load that each pulley has to carry at any given time, allowing for a much more robust setup. The second place we should consider for possible improvements is the armature. Upgrading the design results in better output. Unfortunately, this comes at a price, higher complexity, which goes against a fundamental principle of the whole design, keeping it as simple as possible. However, at some stage the community will be comfortable with the technology and the upgrade might be prudent. Obviously, this is no silver bullet. There are risks and we still need to look at them. First one, pollution of the waters. If these floats are out there in the ocean for a long time, they might start to degrade. Clear maintenance protocols must be in place at all times to make certain this does not happen. Secondly, seabed damage. This is an issue that's of concern to all wave generators. Luckily, the anchors in this design is not attached to the seabed, but still, careful site consideration must be done before deploying any solution. Third, visual annoyance. Large float farms might become an annoyance to the onlooker. This I have an interesting solution to. What if we get local artists involved and they can design interesting shapes, colors, and so forth to make it more appealing? For example, an African flag can be created by changing the color of each float. You end up with a South African flag waving in the water. In the end, these float farms might become a tourist attraction and a boon to the area. Fourth, storms. If a heavy storm hits the floats, the force might be enough to break apart the ropes or the pulleys. Now I have a couple of ideas to minimize the risk. The simplest would be to include a breaking point on the ropes. If the pressure on the rope becomes too much, the breaking point simply snaps, releasing additional rope into the water. To summarize, the setup might not be the most elegant solution, but it makes up for this fact in terms of practicality. It creates electricity in areas where it's badly needed without delay. It's a green source of energy. That's a real boost to the environment. And since burning solid fuel is still the main source of heat in these areas, it will have a major impact on their living standards. It fights poverty since any excess energy can be sold to either the local community or the national grid. But above all, it addresses the one main aspect of social business. It helps people help themselves. This is not a charity. At the end of this project, the community will be self-sustained, giving the power back to the people.